Hey, hi guys. Welcome back to my channel. So we'll be trying something cool, something experimental with Python today. It's not gonna be uh, machine learning really today. It's going to be something related to physics. So we'll be trying to simulate the Young's double slit experiments today. Young's double slit experiment today. So you can see this is the Wikipedia page of the double slit experiment, and what is happening here, guys, you can see this is a picture that I want to show. So here we have two light sources, and these two light sources are called known to be coherent. On a layman term, you can think of it that those light sources have started their lightning event on at the very simultaneous point, right? They have started simultaneously, and that's why they are in phase, and that's why we are calling them to be coherent. And we can, for now, we can consider them to have the same intensity. uh, what's happening is basically, if we had only one light source here, so we would have so this is a screen, and it so when light hits on the screen, it leaves some traces. So very obviously, if we had only one source here, we would have got something like a circular, like a centered pattern. So we would have got a dark part here. By dark I mean intensity. So, and the intensity would have faded away as we move away from the center. But you see here, we are having some kind of pattern, right? So because that's only because we have two sources. So what's happening basically is that two sources are coming together, and at some points they are in phase, and at some point they are out of phase. So when they are in phase, they're doing something called constructive interference, and when they're out of phase, they're doing something like destructive interference. So this parts where, so you see, this is the intensity plot actually. So here we have destructive, so it's actually constructive interference, that's why the intensity is quite high. And as we move out, we see we have patterns, but the intensity of the peaks also are kind of decreasing, which is quite obvious because we are going away from the center. But we have these patterns, right? Sometimes it denses out, and sometimes we it just gets faded out. So we have this pattern. So today we'll be trying to simulate the same experiment with our Python Matplotlib module, and we'll actually generate the pattern we have got here, we are expecting today. Let's see. Okay, so we'll be opening a collab notebook. I had created the runtime beforehand, I guess. Okay. So what? So we have to use something as our light wave. So this sine function will be actually using, like, representing our light wave. So you can think of, so okay. Uh, let's get back to that one once again, that Wikipedia. Okay, so this will be our Matplotlib plot actually. So these are two centers, like two sources, not centers. And the intensity of the light wave for a particular, so what we'll be doing is basically, we will be trying to consider one source at a time. And let's get coding with that part, and we'll try to understand what to do next, right? uh, okay, so let's name this one as double slit experiment. Cool. Okay, we need to import some module, I guess. Import numpy as np, and from matplotlib import pyplot as plt. Okay, uh, it's connecting, it's creating a runtime for the first time actually. Now it's connected, and we have imported the modules. So now what we'll do is basically try to make a grid, like a square grid of all points. So our x is going to be np.linspace. Okay, Before that, we are going to define our limits. So we have x-axis and y-axis basically. So x min and x max are going to be 0 and 10, and y min and y max are going to be, so it's going to be a 2D graph, and you can think of the region we are trying to define here. It's going to be a square region. And now, okay, so what are going to be my x points? Np dot length space uh, this is going to be x mean comma x max x points, and y is equal to np dot length space y mean and y max y points. Okay, what x points and y points are is just like the number of grids we want along each axis, right? So along x-axis and y-axis we are going to have same length actually here, and that's why we are going to do it same for both of them. For now we have 50 comma 50, so we'll be having kind of 50 multiplied by 50, that is 2500 points in our square region. Okay, uh, after that we are going to use np dot mesh grid function. That's going to take x and y as arguments, and sparse is going to be true. So I think that's going to be xx and yy, right? Let's try to see what our xx is actually. Okay, we have got what we are looking for. Cool. X and y. Okay, so what we'll do right now is that we are going to use those points, and so we are actually trying to find out all the points. Our x contains the x axis of the points only, and y is going to have the y axis of the points only. Now let's try to concat them. So yeah, it's going to be x comma y, axis is going to be -1. So you see what we want basically here is that this was our xx, and yy will be also the same. This represents the first axis, like x coordinate of the first point, and similarly we'll be having the y coordinate of the same point in yy. So we'll be just concatenating to have the combined coordinate of that point only. uh, so we need to reshape axis for that. It's going to be 0 because it's just a dummy dimension. Here we have uh, -1 1. Cool. Similarly here also, copy. Okay, let's see what we have got with us. Okay, this is not that good. We are having, okay, okay, so we need to have xx here rather than x only, because this is the one we want, but we have some problem here. Okay, copy. Let's see what our xx 0 is giving actually. Okay, this is cool. Reshape. So what is the error? All input dimension of the condition match exactly, but the array at index 0 has city size. Okay, uh, something has gone wrong here, I guess. uh, I think it should be XX. Reshape. This shouldn't be going like this. Let me think what's actually happening here. I think it should be XX dot reshape. Okay, it says you cannot have that also, because cannot reshape size. Okay, pass. Okay, we should have set it to false actually. That's what's happening, and we need to have this one. So you see, after that our XX would be something like this, right? So it's a 2D array and we need to reshape it. So its size is basically currently its shape would be equal to y points comma x points. We have y points and x points same here. X points, right? So this was just a simple mess because we need to uh, pass sparse as false, otherwise we won't be getting all the points, right? It would be just giving us back the x and y, right? But that's not what we need the whole grid, and for that we need to do something like this only. And reshaping is just going to give us one dummy dimension, so that we can concatenate it. Now I'll show what the points look like basically. Yeah, so we have something like this. Now we can actually do it like this, because we don't need them to be in two dimension, right? We need all the points, and this one looks good. So you see 0 comma 5, then a bit difference, and then -5. So that's what is basically we're going to have. Now points is giving you a region, or like selectively discrete points in a square region, because we can't really have continuous things in reality. So we are going to have like small dots in the square region of -5 to 5 and 0 to 10 region that we have selected here, and we are trying to simulate the values of our sine wave in that region only, right? Let's go forward with that. So as I said, we need to have two sources. So our first source is going to be np dot array. Let's take it, so it's going to be on the y-axis, so our y is from -5 to 5, so we're going to take something like 0.5. Okay, this is going to be 0 because that is the x-axis, and that's going to be on the left side of the screen, and 1 will be at 0.5. We need to have the sources near to each other to have a good pattern, like visualization should be feasible, and that's why we need to have them close here. uh, and the other one will be at -0.5, right? So you have the sources now, and once you have the sources, we can try to find out the distance, right? So our distance will be points 1, that will be equal to points minus source 1, and the next one will be points 2, that is the okay, but still it's in a tuple form. So it's like the Cartesian distance formula says x1 minus x2 square plus y1 minus y2 square, but this points 1 and points 2 are kind of now x1 minus x2 and y1 minus y2, right? So we need to find out the mod of that vector. So these are basically in the vector form, like vector distance. Now we need to find out the distance. So what we're going to do currently is that we'll try to find out the distances now. So distance 1, that is the distance of this points from source 1, that's going to be points 1 to the power, so the x part of the points, that is 2. This is basically to the power 2. This giving us the x axis value or x coordinate value of all the points, and this will give us the y axis value or coordinate of the point. Cool. So we have distance 1 and distance 2 in the same way. Okay, we're ready to rock. Now this is the square distance, but we need to find out the root over that. So this is basically the Cartesian distance formula that you can find from internet. Do a square root, so it should be 0.5, right? So this is what pretty much of it. Now the formula says you should have a sine. So this is the intensity of the light, or called the amplitude. It's not the intensity actually, but it is amplitude multiplied by sine of the distance, that is, let's say, x multiplied by k, that is the path distance or wave number we called. So those are the two things we need to set up here. So a1 is going to be the amplitude of the first wave, that is, let's say, 4, and a2 is going to be 5. Okay, let's keep it same for now, and the k should be same for them, so let's take k as 20 for now. Now we need to give the formula. So it's a1 multiplied by, okay, I'm just trying to follow the formula that they have given. So a1 multiplied by np dot sine, that this is the sinusoidal function we have with us, and inside that we need to have a k multiplied with this distance factor that we have got with us. So it's going to be k multiplied by this, right? Similarly, we'll be having the same one here, but a2, right, because this is for the second source, and yeah, so similarly, so let's see it's running or not. Okay, we have some formula. Okay, it's going to be a small k, not okay, it should run now. Cool, it's running. Now we'll just try to print the distance we have with us. It should be distance 1. Okay, it's working. So currently what you need to see is basically this shape is basically going to be 2500, as I said, for each of the points. So we have 50 along x-axis and 50 along y-axis, so we multiply it, we get all the points in our region, that is 2500. So this is the distance value of each of the points from source 1, and distance 2 will be the distance from each of this point to source 2, right? Now, so this actually not the distance, this is the wave value. right? And it has a direction, like, so sign value can be minus, right? So what happens basically is that this wave 1 is kind of a fluctuation of like sinusoidal fluctuation over all the regions in the given grid, and so is wave 2, but wave 1 is being caused by source 1 and wave 2 is being caused by source 2. Now what we'll do now is superposition of two waves, right? So superposition of two waves says for each of the point the amplitude, that is A, is going to be the intensity caused, or value, wave value actually, the wave value caused by the first one square, sorry, the first one vector sum of the first one and second one, right? So this one, and that's all, right? So what will basically happen is that some cases both wave 1 and wave 2 will be strong and positive, and both will be strong and negative. And because A is basically the amplitude, and we'll actually have intensity with us, so intensity will be A square, right? So when both of them are negative or both of them are positive, right, so they're kind of bringing up the intensity, right? But when one is negative and the other is positive, they're bringing down the intensity. So it doesn't matter it's negative or positive, if they're similar, that means both have same signs and also both are high in value, that means they're bringing up the intensity. The other way, if they're having different signs, they're kind of decreasing the intensity. So when they're increasing the intensity, we call it constructive interference, sorry, and when they are decreasing the intensity, we call it destructive interference, right? So we have our intensity with us. Now what we'll do is that simply plot it, right? So we just need to plot it and see if it's working or not. So let's try to plot it. plt.xlim, so it's going to be our x min to x max, right? We already have defined the constants, and y min comma y max, right? This is the y lim, there's a limit of y axis. Once we have that, we'll try to plot this particular thing, that is using the scatter plot. So we have our points, which are points x-axis and points y-axis, and the intensity, right? So the intensity is basically this intensity variable, that's a sequence or a array, numpy array here, and we are going to use some cmap for now, that is cmap is equal to plt.cam.binary. That's just for visualization in grayscale. Hit it. Cool. So we need to just, okay, we need to give the figure some fixed size. Plot dot figure, I think it's figure, yeah, it's figure. So fixed size, oh, fixed size equals to, okay. So what's happening basically, you can see the patterns being generated here, but a better pattern can only be generated when you have more this number of points, but you can kind of guess what's happening here. The same thing that was happening in that Wikipedia article is that we have two sources here, those two sources are, okay, well, let's try to plot the sources here now. Plot dot scatter source 1 C equals to yellow should work. Okay, we need to increase the size actually. So S should be say 4. Oh, we can't see it. Let's try to increase this to 20. I think it will be too big to see. Okay, it's not working. Let's keep it red actually. Okay, so we have the two sources and the light is coming out of it, and if we had a screen here, we would have got something like a pattern here, which is quite similar than this. So you can think of this boundary as a pattern, and so this boundary as a screen, and if we had a real experiment occurring here, we would have got something similar to this. Now I would try to increase the points for a better visualization. So I've just increased the number of points, so now you have more pixels. So basically this is a kind of acting as pixels. Now we had 2500 pixels then, now we have 40,000 pixels. And now you'll be seeing the improvement here in the visualization part in the plot. It will take some time. Yeah, cool. So we have two light sources here. Here you go. This is the exactly thing we were talking about. Let's see if that looks cool or not. uh, okay, this one is also not bad, but the correct one will be this, because the white part is basically no light, okay, and the black part is basically a lot of light, right? So that's what is actually happening. Thanks guys. So we'll see in the next part, try to simulate the sine waves, how they are propagating, okay, and we'll be seeing how what is basically causing this to happen, right? uh, See you again.